Hi everyone, this is the difficulty hard set for imaginary numbers for SAT practice. So basically they just want you to see which is the following is the equivalent to this. Basically it's hard because we've got these radicals and all that, but basically it's no different than this medium set. It's just a few extra steps. So I'm going to rewrite this as 10 minus, and I'll write over here, this can be written as negative 4 times 3. So that's basically 2i square root of 3. And the denominator, this negative 27, can be written as negative 9 times 3, which is going to be, so it's 1 minus, that's going to be 3i square root of 3. Alright? So just simplifying radicals here. Now what I'm going to do is multiply the denominator by the complex conjugate, which is 1 plus 3i square root of 3. If I multiply the denominator by that, I have to also multiply by the numerator. Now I know when you multiply by the complex conjugate here, that it's going to be, and I'll put it up here, a minus bi times a plus bi equals a squared plus b squared. So that's all I'm going to do for the denominator. I'm going to do that first. So my a is 1, so 1 squared is just 1, and then we're going to have a plus, and my b is, we can take away the I, so my b is just 3 square root of 3, and I have to square it. So that's going to give you 9 times 3. This is 9 times 3, which is 27. So basically my denominator is going to be 28. Now the numerator is the hard part, so let's go ahead and take care of that. We're going to get 10 plus 30i square root of 3 minus 2i square root of 3 minus 6i squared square root of 3. Now I know I squared equals negative 1. So I'm going to take care of that right now. This is I squared. I'm going to take this off. And negative 1 times a negative is positive. I just changed that. So now I can combine like terms. And I have, so that's going to give me, let's see. Is this a square root of 3? Oh, this is just supposed to be 3. Sorry. You can tell usually because you, okay, so basically it's 10 plus 18 is going to be 28. So you have 28. And then this part right here is going to be plus 28i square root of 3 over 28. And if you reduce everything by 28, you're going to get 1 plus I square root of 3. So that gives you this. Okay, the next one is very similar. Basically, we have two complex numbers, 3 minus 2i and negative 2 plus 4i, and we want to divide it and simplify. So basically, we're just putting 3 minus 2i over negative 2 plus 4i. Now I'm going to go ahead and multiply this by the complex conjugate of the denominator, which is negative 2 minus 4i. And then you also have to do it in the numerator. Alright. And we know the denominator, when you multiply a plus bi times a minus bi, you get a squared plus b squared. So in this case, my a is negative 2, and my b is 4. And when you square that, you're going to get negative 2 squared is 4, and 4 squared is 16. Now we have to take care of this numerator, which is the hard part. So when you FOIL all this out, you're going to get negative 6 minus 8i. Oops, sorry, I'm skipping steps. So let me not do that. So we have negative 12i plus 4i plus 8i squared. And again, I squared is negative 1. I squared equals negative 1. So I'm just going to take that out and change this to a negative. Change the sign in front. Now simplify the numerator. We're going to get negative 14. That's these two. And then when you combine these, you get minus 8i all over 20. And simplify, I'm going to divide each of these pieces by 2. So you get negative 7 minus 4i over 10. Now they have this spread out, so it's negative 7 over 10 minus 4i over 10. Now, since it's not one of the answer choices, what we're going to do is just further reduce this right here. So we get negative 7 over 10 minus 2i over 5. And that's your answer. So the answer would be B. Okay, the last one is we have two complex numbers. In this case, we have k here is a constant. So they say if a times b minus 15 is 60, then what is k? And this is a griddable. So what we want to do is notice that ab actually equals 75. I'm going to add 15 to both sides here. The next thing I want to do is multiply a and b so I can figure out what this is. So basically I have 3 minus 4i times 9 plus ki, and that's going to equal my 75. So I take care of that. We're going to get 27 plus 3ki minus 36i minus 4ki squared equals 75. Now, I'm going to go ahead and take care of the negative 1 here. This is negative 1, so I'm just going to change that to a positive. And what I'm going to get is 27 minus 36 I'm grouping my k's together, plus 3ki plus 4k equals 75. Now, I basically have two options. The only way the expression on the left can equal the 75 is if the imaginary terms add up to 0. So you can set the two imaginary numbers equal to 0 and solve for k. For example, we would take negative 36i plus 3ki equals 0. So I'm taking this part. And then you get 3ki equals 36i. And then you get 3k, because the i's cancel, equal 36. So k is 12. So that's how you set that. Okay, or the other way is to ignore the imaginary term, because they add up to 0, and set the real terms to equal 75. So my real terms are going to be 27 plus 4k. Those are the ones without the i's in them. And set that to 75. And when you do that, you get 4k equals 48, and k is 12. So any route leads to the correct answer, which is 12. And that's a griddable. Thank you. Have a nice day. Bye-bye.